All right, good morning. It's March 31st, 2021, and it's time for Dr. Schleith's APOD game. If you feel like you've got a good idea about what this picture is, go ahead and call it out or leave it in the comments down below. It is a picture of a black hole, so can anybody be more specific than that? So black hole will win unless somebody can say particular name of this black hole or what galaxy it's in, or be more specific here. It is not Sagittarius A star, although the experiment that was conducted that collected the data that led to this image also collected data on Sagittarius A star. They've yet to really publish anything about that, so that's something to look forward to. So Sagittarius A star is the supermassive black hole at the center of our galaxy, the Milky Way. This is another supermassive black hole at the center of the galaxy, not Andromeda, but M87. And so what's new about this one is these little swirly lines. All right, so the light is actually polarized, and they've reprocessed the image to sort of add in these lines here so we can kind of visualize the way that the matter sort of swirls into the black hole. Once we conclude the lesson on dark energy, we're going to look at giant black holes, quasars. Okay, so quasar is an acronym that stands for quasi-stellar radio source. And our best hypothesis about what a quasar actually is a giant black hole that is ejecting matter out sort of along the poles. So if this is sort of like the north pole of the black hole, matter is sort of like being ejected towards sort of our line of sight. And magnetic fields are a way to sort of explain how that's possible, because you think of a black hole as sort of consuming mass, right? So the matter falls into it. It's a very strong gravity field. It's a sort of millions of stellar masses, so millions of stars worth of mass inside of the black hole. But one of the features of these active galactic nuclei, like M87, it's an active galaxy, are these powerful jets that we sort of observe as quasars. You may recall we looked at the Big Bang theory. One of the lines of evidence that sort of led to this idea that the universe is changing and not sort of a steady state or a static universe is the idea that there was this age of quasars. So there tended to be a lot more quasars in the past than there are today. So it's sort of like the galaxies have sort of quieted down and consumed all the matter that they possibly could, but we still see evidence of like, a black hole ripping a star to shreds as it sort of falls into it. Let's read the description. It says, to play on Carl Sagan's famous words, if you wish to make black hole jets, you must first create magnetic fields. The featured image represents the detected intrinsic spin direction polarization of radio waves. The polarization is produced by the powerful magnetic field surrounding the supermassive black hole at the center of elliptical galaxy M87. The radio waves were detected by the Event Horizon Telescope, EHT, which combines data from radio telescopes distributed worldwide. The polarization structure mapped using computer-generated flow lines is overlaid on EHT's famous black hole image, first published in 2019. The full 3D magnetic field is complex. Preliminary analyses indicate that parts of the field circle around the black hole along with the accreting matter, as expected. However, another component seemingly veers vertically away from the black hole. This component could explain how matter resists falling in and is instead launched into M87's jet. We'll see you next time.